You think you're safe on a 200-meter cruise ship. Think again. Imagine a vertical wall of water as high as a 10-story building, raising from calm sea, coming straight toward you. For centuries, Siens laughed at sailors who told such stories, called them fools, drunks, liars, dismissed their testimonies as maritime folklore, like the Kraken or Atlantis. But today, cameras film the impossible. Jet skis thrown 6 meters into the air. Armored windows pulverized 20 meters above sea level. Steel balconies ripped like paper. These are no longer myths. These are rogue waves. And they are hunting. For centuries, rogue waves existed between nightmare and reality. Sailors spoke of them alongside sea monsters and ghost ships. 30-meter walls appearing without warning, capsizing vessels, vanishing instantly. Stories told by men who watched crewmates disappear into churning chaos. Science dismissed these as impossible, mathematically absurd. Mermaids and Atlantis. A wave visible from space could not exist. The physics did not allow it. The equations did not permit it. But the ocean does not care about equations. Jules Dumont d'Urville, 19th century French explorer and naval officer, witnessed 30-meter rogue waves in the Indian Ocean. 3 eyewitnesses corroborated his account, verified his measurements, confirmed the horror. It amounted to nothing. Dumont was publicly ridiculed, mocked in scientific circles. Even the French Prime Minister dismissed his fantasies. The message, rogue waves did not exist. Anyone claiming otherwise was delusional. For nearly 150 years, the concept disappeared. Skeptics remained firm. Such waves were impossible. And if they existed, no one would survive to tell the tale. Scientists refused to acknowledge rogue waves because of linear wave theory. They believed wave energy traveled in predictable patterns, created by wind friction and gravitational pull from sun and moon. Using mathematics, they calculate wave sizes precisely. They developed significant wave height, the average of the tallest 1/3 of waves at an eye point. Based on these calculations, oceanic waves could only reach 9 meters maximum. A 30-meter wave, once every 10,000 years. The ocean had not read the textbooks. With steel-hulled ships in the 20th century, survival probability increased. So did reported sightings. Between 1969 and 1994, 22 super carriers vanished from rogue wave impacts. 525 sailors died. Ernest Shackleton's 1919 account during his 1,300-kilometer voyage in a 7-meter whaler captures the terror. I called to the other men that the sky was clearing. Then I realized what I had seen was not a rift in the clouds, but the white crest of an enormous wave. We felt our boat lifted and flung forward like a cork. We were in seething chaos of tortured water. Somehow the boat lived through it, half full of water, shuddering under the blow. Despite this testimony, despite the mounting deaths, science held firm. Ships continued to disappear. In 1978, a 240-meter cargo vessel simply vanished in the North Atlantic. The mystery would haunt maritime investigation for decades. But science needed more than stories. It needed proof. Irrefutable, measurable, undeniable proof. In 1980, Philip Blazor captured one of the first ever photographs of a rogue wave of the east coast of South Africa. The image was grainy, taken from a distance, but unmistakable. A massive wall of water towered over its neighbors, frozen in black and white film. The wave roars like a cliff phase from the surrounding ocean, defying every prediction, every mathematical model. For the first time, the phenomenon had visual documentation. But traditionalist oceanographers remained skeptical. Photographs could be questioned. Angles could deceive. Perspectives could mislead. Wave height estimation from a photograph was considered unreliable. They wanted precision instruments. They wanted laser measurements. They wanted data that couldn't be argued with. Science demanded certainty. January 1st, 1995. While the world nursed hangovers, Draupner oil platform crew steadied themselves in the turbulent Norwegian Sea. The platform's downward-pointing laser-tracked sea state continuously, measuring wave heights with precision instruments. That morning, it measured a 25.6-meter wave. Engineers had calculated the North Sea might produce a 20-meter wave once every 10,000 years. But 25.6 meters? Not in the equation. This wave was more than twice the surrounding 11-meter waves. The laser didn't lie. The data didn't deceive. The measurement was absolute. Scientific denial collapsed overnight. Linear models were discredited. The Draupner wave changed everything. Rogue waves must be at least twice the significant wave height. But how do they form? Scientists have identified three main theories, often working in combination. Waves traveling at different speeds and directions pile into each other, creating one giant wave. When swells pass through each other, crests and troughs coincide, reinforcing each other. Multiple waves staking energy into a single massive formation. It's simple physics, but the timing must be perfect. When it is, the result is catastrophic. When powerful swells encounter massive contrary currents, energy compresses. The wave's base slows down as it hits the opposing current. The crest keeps moving at full speed. Result: a nearly vertical wall of water, steeper than naturally occurring waves should be. The Ugalus current off South Africa is deadliest. Flowing southward at 5.8 miles per hour, it's one of the fastest currents in the ocean. When storm waves traveling north meet this southward rush, compression occurs. Wave heights increase by 60% in extreme cases. The current has been responsible for sinking 150 ships in recent decades. The Gulf Stream presents similar dangers, possibly explaining some of the mysterious Bermuda Triangle shipwrecks. Non-linear theory demonstrates wave components can interact and exchange energy without external cause. An unstable large wave becomes a predator, sucking energy from smaller surrounding waves. It feeds, grows exponentially. Scientists at Austrian National University, Hamburg, and Turin demonstrated this in 2012. The wave reorganizes the ocean around it. This is the quantum effect. While scientists debated theories in laboratories, big wave surfers tested these forces with their lives. But these physics don't just lurk in theoretical models and ocean randomness. They explored at coastlines where underwater topography transforms normal swells into rideable monsters. These athletes chase massive swells at places like Nazaré, Portugal, where an underwater canyon forces waves upward to spectacular heights of 28 meters. Breaking waves are predictable, formed by seafloor topography. But even in these controlled environments, rogue waves strike without warning. Alex Botelho, WS El Big Wave Tour Surfer, was operating as rescue personnel on a jet ski when the ocean revealed its chaos. Two massive rogue waves collided in front of him, their energies combining in a violent demonstration of constructive interference. The collision created a vertical explosion of water. The jet ski was launched 6 meters into the air. Not lifted gently, thrown. The machine tumbled through space, its engines screaming, before crashing back into the churning water. Botelho was separated from the craft, swallowed by white chaos. Rescue teams found him unconscious, drifting face down. Severe drowning. His lungs had filled with seawater. He spent days in intensive care, fighting for breath. The ocean had nearly taken him. When he recovered enough to speak, he announced his retirement from professional competition. The jet ski taking flight became one of the most spectacular images of rogue wave power ever filmed. Dylan Longbottom was filming at Shipstern Bluff, one of the most dangerous surf breaks on Earth, when he encountered something that shouldn't exist. A rogue wave of extraordinary width and density approached. Not just tall, thick, dense. A massive volume of water compressed into impossible geometry. The wave phase deformed as it traveled, developing visible steps inside it. Multiple layers of water stacked at different angles, creating a mutant structure that demonstrated non-linear physics in terrifying real time. When it struck, the impact was catastrophic. The wave exploded on Longbottom with the force of a collapsing building. His chest compressed so violently, his lungs nearly ruptured from internal pressure. The wave picked him up and threw him against the rocks like debris. His body shattered against stone. Emergency helicopters airlifted him to the hospital. Severe internal trauma, broken ribs, Lung Kuntuzuns. He survived, but belie. The footage shows what happens when a ROG wave's density becomes the weapon. Sion Milosky was an elite big wave athlete, respected as one of the most skilled watermen alive. On March 16, 2011, he paddled out at Mavericks, California. The conditions were massive. The ocean was angry. Then the ghost set arrived. Ghost sets are ROG waves appearing from a different direction than the prevailing swell, giving surfers no warning, no time to escape. The first wave was enormous. Milosky dove under it. The second wave was even larger, abnormally massive. It caught him mid-dive and drove him deep underwater, holding him down as thousands of pounds of water cycled above. Before he could surface, the third wave struck. Milosky drowned. Holed underwater by successive waves, unable to reach air. His body was recovered hours later. He was 5 years old. A father. A husband. A legend. His death shattered the big wave surfing community and changed the sport forever. Engineers developed the inflatable safety vest in direct response, a high-pressure system that can be manually deployed to bring drowning surfers to the surface even when hauled down by successive waves. The vest became mandatory worldwide. Sion Milosky's legacy is unmeasured in the waves he rode. It's measured in the lives saved by the technology his death inspired. Despite artificial intelligence, satellite monitoring, and engineering capable of building ships over 300 meters long, humans remain vulnerable to the ocean's unpredictability. The evidence continues to mount in the modern era. That same year, the Draupner wave was recorded. The Queen Elizabeth II was en route to New York from England when a ROG wave over 27 meters struck the vessel. The wave smashed windows in the Grand Saloon, 21 meters above the waterline. The captain later described the moment in haunting terms. It looked as if the ship was heading straight for the white cliffs of Dover, not metaphorically. A wall of white water so massive, so vertical, it appeared as solid ground rushing toward the bridge. Physics had transformed like within 2 cliff phase. All years later, researchers aboard the British vessel RRS discover recorded their T-meter ROG wave off Scotland. The ship was equipped with precise instruments. Months after returning to port, scientist Penny Holliday analysed the data. They'd experienced the largest waves ever scientifically recorded in open ocean. The wave caused the ship to heel 28 degrees to port, roll 30 degrees to starboard, then recover. According to all theoretical models, waves of this size should never have existed under those conditions. But the carnage didn't stop in the 1990s. The Norwegian Dawn, a luxury jaunt, was traveling in the North Atlantic off Georgia when an isolated rogue wave measuring 21 meters struck. The wave reached deck 10. Massive flooding destroyed 62 luxury cabins. Steel balconies were torn off the hull. 4 passengers sustained minor injuries. 4 passengers on deck 10 to witness water reaching their level is to understand true terror. The Viking Polaris, an ultra-luxury expedition ship, was crossing the Drake Passage between Antarctica and Argentina when a massive lateral rogue wave measuring 7.6 meters struck. This wave shattered floor-to-ceiling windows in passenger cabins. 1 passenger was killed by glass shards. 4 others were injured. The cruise was cancelled. The ship was designed for harsh polar conditions. Yet a 7.6-meter wave was enough to breach the hull and kill a passenger. Now we return to the ship that vanished. The MS Munchen was 240 meters long, one of the biggest cargo vessels in the world. Built to withstand 15-meter waves and considered unsinkable, it issued a 3:10 a.m. distress signal on December 12, 1978, somewhere in the frigid North Atlantic. That SOS was the last anyone heard from the crew. The search operation that followed was the largest ever conducted in the North Atlantic. 13 aircraft took flight, circling through freezing winds and sleet. Over 100 cargo ships in the busy shipping lane diverted course to join the search. For days, they scoured thousands of square kilometers of empty, hostile ocean. The water temperature was near freezing. Survival time for anyone in the water, minutes, not hours. They found nothing. No survivors. No debris field. No oil slick. Just empty ocean and the growing realization that a ship the length of 2 football fields had simply ceased to exist. Months later, recovered lifeboats finally revealed the truth. They'd been bolted 20 meters above the waterline, the equivalent of a 6-story building. They hadn't been lowered by the crew during evacuation. They'd been ripped from the ship's stern by catastrophic force and hurled into the ocean. Steel hinges were bent backward, twisted like paper clips. 100 tons of force per square meter. Ships are designed for 15. No survivors. Only forensic evidence proving rogue waves can erase ships from existence in moments, leaving nothing but questions and grief. In November 2020, the most extreme rogue wave ever recorded was measured off British Columbia near Ucluelet. The wave reached 17.6 meters high, 3 times as tall as surrounding waves. The most extreme size difference ever observed. It occurred nowhere near traditional hotspots. Not the North Sea, not South Africa, not Drake Passage. It emerged in British Columbia, proving ROG waves can strike anywhere, anytime. Humanity is not accepting defeat. Technology is fighting back. Researchers at the University of Maryland have developed neural networks capable of predicting ROG waves up to 5 minutes in advance. Using a dataset of 16 million sea surface elevation measurements from 172 buoys located near the shores of the continental United States, the team processed thousands of ROG waves to train their AI systems. 5 minutes of warning. 5 minutes to change course. 2 secure passengers. 2 brace for impact. But this technology hasn't been deployed outside controlled environments. The ocean remains uncontrollable. Following Sion Milosky's death, high-pressure inflatable life jackets became mandatory for big wave surfers. These vests can be manually deployed to bring drowning surfers to the surface even when hauled down by successive waves. Shipbuilders have strength-end armored glass and reinforced bridge structures on expedition vessels. Engineers now design for forces exceeding 100 tons per square meter, acknowledging that the hold 15-ton standard was catastrophically inadequate. But despite all this technology, despite these precautions, the data tells a humbling story. Between 2011 and 2018, 210 ROG waves were officially reported worldwide. Ships still suffer damage. Passengers still die. We have built 200-meter steel giants and created artificial intelligence to monitor the ocean. We have turned our surfers into astronauts of the seas with futuristic survival equipment. But faced with a force capable of pulverizing 100 tons of steel per square meter, is technology a shield or a mere illusion? In your opinion, will human beings eventually tame nature? Or will they always remain prey as soon as they head offshore? Are we truly stronger than the ocean? I look forward to your verdict in the comments.